Sweet. So, who has questions?
I already told you my question.
I still don't really understand the project. Like, what are we supposed to do and stuff?
Okay, so do you want to talk about the project again really quick first, and then we can talk about the lab?
Wait, so what I understand so far is that our project is to make a essay or a video explaining about what we've learned so far about light.
I mean, that's pretty much it, right?
Yeah, that's the basics of it. So it could be
Wait, so what
however you want it to be. For example, Max had a good idea. I don't think he cares if I share this with you guys, because you can do the same one if you want. Would be to even put some of this stuff in a website. So if that's something that would be easy for you. But again, I called it a mini project because I don't want, it shouldn't require you to spend as much time as a normal project that we do in class. Like it's
Yeah.
Because
so
taking stuff
even like
online
last week, you made short videos about sound, like even something like that. Those were really good. Would be good for this too. But one thing that I want you to add is something where you're demonstrating it like hands-on activity, something you're doing. So
what do you mean hands-on activity?
I give some examples here. You could do other ones, but for example, you show the bending pencil for refraction of light, right? You explain that. So it could be as simple as that. You could make a Newton wheel, which is cool because it shows like.
Oh, wait, so we have to make like an example of one of those? Oh.
But again,
No.
it could be simple. It could be a little more complex, but there are lots of good examples here, more easy and more difficult. Even if it's just you showing different colors of paper to explain what bounces off of them, right? But it's something physical you're using to explain.
I mean, like it can just be as simple as putting the pencil in the cup of water, right?
Maybe. Yep, you put the pencil in the cup of water and you explain why it looks bent. That would be a good one.
Okay.
Oh, okay then.
Yep, so that one's listed right here too.
So
There's a lot of
basically
them.
explaining, right?
Wait, if I'm doing a PowerPoint and if I'm doing a PowerPoint, do I take a picture of it and explain it while recording the PowerPoint?
That's one way to do it. You could take a picture, or you could like add a short, because you could add a video to a PowerPoint, so you could show within it like a short 30 seconds of you showing it and explaining it.
Wait, so if we do something like a website, do we need
to video
like,
in a video?
Do we need to like explain it, or like if we do something like a website?
If you did a website, I would expect like maybe at the very beginning you have a short intro video, but you don't necessarily have to make a video of you explaining the website. You don't have to do that.
Okay.
It kind of just depends on how self-explanatory it is to look at. So, but that's why I want you to turn in like a formative part next week, so that if I think that it isn't well explained enough, I can tell that to you first before I give you your final grade. So, yeah. Any more questions about that?
Is everything we need to put in our presentation on that Word document?
Yes, but I'm not requiring you to finish it all by Tuesday, so it's just the first couple parts you're doing. But everything is on that first list on the first page. That shows everything. Yep. So again, the intent is not to make it a huge project. It's still a mini project, but instead of me telling you, this is how I want you to show me you learned about lights, you can choose how you show me. Can you do that best through talking? Can you do that best through typing? That's kind of your choice. So the intent is to make it easier for you, not more difficult for you. So I don't expect you to spend hours and hours and hours on it. I just expect you to show me what you know. That makes sense, everybody?
Okay. So it's basically kind of like last week's video. It's just with some more extra stuff, right?
Yep.
Yeah, yeah.
So this
So,
time,
so it's basic. So it's
longer to do
basically
it.
just
There's a
teaching,
little
right?
more, but it's the same concept as last week.
Wait,
Basically
so
just
okay.
teaching. So,
wait,
right?
may we just make a video like while explaining it, or do we need to
You could do that.
like just a video of us?
Yeah.
Oh, okay, then I'm not doing the PowerPoint.
Miss Hannah,
I think I'm gonna do the
Yeah.
PowerPoint too. Seems easier.
I still don't understand about the colors, like the three additive, so like the three additive like primary colors and the three subtractive primary colors. I still don't understand. I know what they create, but I don't know how they work. I still don't understand. I know how. I just don't like get it as much.
Okay. We could talk about the additive colors. Did anyone else have a question about the additive colors?
It's just mixing colors, right? Like,
Yeah, like this color
It's-
mixed with this color turns into this color, right?
well, not really mixing, like absorb.
Putting
So
one on top of
absorb.
another.
Yeah, I just well, I understand it. I understand it.
Do you want to try to explain real quick, Chris, while I try to find a picture?
So for example, if I have a red window, so for example, I have a yellow window. So if I have that white light thingy and I shine it through it, the light that passes through it will then become yellow. The reason it becomes yellow is because the color blue is absorbed by the yellow glass, and the color green and red are reflected, so it creates the color yellow, because when you mix green and red, it becomes yellow in that sense. So that's why it reflects into yellow, because it mixes the red and the green.
Okay.
Yeah.
Yeah, I get a better understanding now. Thank you. Thank you.
Good job, Chris. Well done. I could share this picture with you too. So like this is what Chris was saying, the red and the yellow would make the yellow, because if we think about subtractive, this is what we're used to, right? We're used to if you mix yellow and blue, you get green, but that's because we only see what's reflected to us. So yellow and blue, you're just subtracting all the colors that don't get reflected, right?
Wait, so my explanation was correct, right?
Yeah, that was a really good explanation.
Yay!
So just kind of expanding on it a little bit. So subtractive colors, these are the colors that are absorbed. So that means if you have paints and you mix yellow and blue, they will absorb all the colors except for green, and that's what it will reflect back to you. Whereas if you have additive colors, this is the light itself. So you have all the colors that you see from the red shining, plus you have all the colors you see from the green shining. And when those go together, you see the yellow. So that's why when you add all the colors together, it makes white lights. But in subtractive, if you add all the colors together, they absorb all the light.
Get back.
So nothing is reflected because it's black.
So that means that if like you combine like certain colors, you can to get green, it's subtractive, right? Not additive, right?
Right.
No, that's
Mixing paints is subtractive
wait.
color.
Oh yeah.
And lights is additive color.
Okay.
Yep, because we add the lights. Where subtractive, we take away the light. Whatever it absorbs, you don't see. So like if I'm looking at a leaf, it's actually absorbing most of the colors, just except for green. That's the only one it reflects.
Oh, okay.
It'll change the way you think about things, because whatever color you see it, that's actually the only color it doesn't like. So are plants actually green? I don't know.
Well, to some people they aren't.
Well, technically, plants have chlorophyll in them, which make them green, right?
So chlorophyll is,
To
and this
us,
is one
it's
of the
green.
questions on your lab, but chlorophyll will absorb different wavelengths of light, and that's how it makes energy. So the wavelength it absorbs are kind of in this purple, blue area. It absorbs a lot of those, and it absorbs a lot of the reds and oranges, but it doesn't really absorb these green colors. So it looks green because it doesn't use green. It doesn't need it.
Oh, okay.
Wait, is that the reason why if someone wanted to make a indoor like greenhouse, they use blue light?
Yeah, kind of, because it needs a lot of that blue light, right? So let's
Oh.
imagine that you put like a green filter right here. Let's imagine you put a filter here and it was green, right? Well, if your filter is green, then only green light can come through. So your plant wouldn't get red. I will be right back. I'm gonna get my stylus so I can actually draw it. So that would mean you would not see blue, you would not see red. They wouldn't make it through the filter. So if in a greenhouse you gave it green lights, would the plant grow?
Yes.
No.
No,
Wait.
because
Yeah.
do plants, they don't absorb the green light, right?
Oh, right.
So if you only gave them green light, they couldn't grow. Whereas, like you said, if you were to give it blue light, which is the most energetic light, by the way, that's why it's not good to look out before you go to bed. If you were to only give it the blue lights, and blue light could come through, but you stopped all of the red light and green light, well, it does need the blue, right? It doesn't have the red, so it doesn't have all of it, but it still has blue, so it would grow pretty well. Does that kind of make sense to everyone?
Yeah.
Yep.
All right, next question. Which part did you have a question on, Chris?
Wait, scroll up. Yeah, that part.
Right. So to help you with this, I need to go to
The incident and the where is it? The incident and the reflection angle.
Mhm.
They have the same length, right?
So in your angle of,
Angle of incidence and reflection, they have the same length, right?
mhm. So
Okay.
this is kind of how we label an angle here, like theta. They would be equal to each other.
Wait, we need to label that later.
You don't need to, whoops. You don't need to label it like that.
Wait, so what's the thing for number 5? Like, what do you need to do for number 5?
So number 5, you're going to show a few angles. You're going to measure the reflected ray, right? And you'll also measure the refracted ray. So if it's going from something like air to glass,
Yeah.
the refracted ray will become smaller than the reflected ray. So reflected ray is equal to incident ray. These ones, they're equal. But between the incident ray and the refracted ray, it becomes smaller. So let's look at the,
Wait, so that's what you need to do for number 5?
yep. So if we look at our simulator here,
Oh no, you use a simulator again?
Can I shine this? Okay, so I put this down here. Make sure you match it up. You guys learn how to use these math.
Nah.
Yeah. So I matched up the 90 degrees right there.
Uh-huh.
And then I need to figure out what is the angle of incidence. That's this one, right?
Wait, I don't understand what we're supposed to do. Wait, what?
So let's say we need to find the incident angle, right? Incident angle, reflected angle, and refracted angle. So this is the incident ray, the first one, right?
That's the
In
incident.
order to
The
find
angle.
the incident angle, you would see how many degrees over here it comes. So it's more than 30, less than 60, right? It's right in between those, so it's 45 degrees. The angle of incidence is 45. And if that's true, your angle of reflection should also be 45 degrees. Okay, and if that's true, then my angle of refraction should be smaller than my angle of incidence and my angle of reflection. So if I look at it down here, we've got somewhere between 30 and 35, right? Would you guys say that's about 32?
Wait. Miss Hannah, how do you find the angle of refraction?
So right here, you see on the protractor, how it hits
Yeah.
right at about 32? That's the angle of refraction.
Oh yeah. Okay. I gotcha.
So then, if you wanted to try this again with a different angle, you could just move this to whatever angle you wanted. Okay, so let's say I do 60 degrees instead of 45, right? So,
But then for the worksheet, what are we supposed to do?
so you are just listing those degrees. So like, if your incident angle was 45,
So we need to do 2 different degrees for each?
so reflected would be
Oh, yeah, I was confused for why there were 2 boxes. Oh.
and then
And what's that
you
big
would
box for?
draw.
Oh.
Yep, and then you could label the thing. So
Wait, what if we type it?
so you can always go to inserts, and under shapes there are lines.
Oh,
So
okay then.
you could just insert the line like that.
And what about label?
Label, what I normally do is insert, under the first shape there's that text box.
Uh-huh.
So you could say incident go up to the drawing tools with the format, you can make it so it has no outline. and then it won't mess with covering up things. You can move it right up there. Does that help, Chris?
I guess.
The index of refraction right here, that one would be from the object itself. So every object has a different index of refraction, and basically it has to do with how fast light can move through it. Because remember, the speed of light will change based on the object it's going through. So your index of refraction for air is 1. So we compare these things off to air, right? The water has an index of refraction of 1.33. There's actually a mathematical formula you can use called Snell's law with refraction, index of refraction, and then you can find the angle of refraction. But I'm not going to make you guys use the mathematical equation. You can just use the simulator to measure it. But you could list it. Like I could change the index of refraction, and you could see how that angle of refraction starts to change. And if it were just air, it would all go through. None would be reflected, none would be refracted. If it has the same index of refraction. Any other questions?
Max texted me he wants to wax his hair.
What?
What?
You wanted to wax my hair.
Nah.
What? A question or a comment? Hey, Jeff
What the
is here.
So you know how you wax your armpits? I'm gonna do that to his head.
No one waxes their armpits. No one does that.
Yeah, that's the thing I told him. Nobody does that. And how does he know?
People wax their legs, not their armpits. Oh my.
People
Oh, I
wax
thought they
their
wax-
armpits too.
Ha!
They do,
Yeah,
Saul.
you do.
Yeah, idiot.
That's not nice.
Yeah, that's not nice, Chrissy. You hurt my
Yeah, that's
feelings,
not nice,
Chrissy.
Chrissy.
You hurt my feelings,
Talk about that
Chrissy.
stuff all the time.
But I love your feelings, Scott.
Wait, Scott,
Who's
Chris
talking?
hurt your feelings by saying that people could not wax their armpits?
No, we called me an idiot, didn't you hear? See, miss? Take a point off him, miss. Bad language,
Not
miss.
here,
Bad
that's
language.
fine.
Bad language.
No, that's big damage.
What's the most points?
Jeff attended. I'm so happy.
Whoa.
Andrew still hasn't attended. Well,
You guys gotta
That's
get into
shocking.
Chrome. But we were at least talking on Teams today, so that's something. But yeah, you guys get him to come. This was a good Q&A attendance, though. Glad lots of you came. Do you have any more questions?
How do we make the line for the drawing into an angle if we do it like in Word?
I'm not expecting you to measure the exact angle, but make it approximate. Because you already
Okay,
told
then.
me the exact measure of it above.
Okay. Do we need to say what we're trying to say the angles are supposed to be, like the degree of the angle?
Not in the drawing, because you listed
Okay, then.
people. So you just need to label things on the drawing. And then I'll know.
So drawing we label incident, reflection, and what's that? The third thing, right? Which is which?
I believe I made a list for you here. Yeah,
Oh, okay.
and don't forget about normal. Normal is that 90-degree line, which is pretty
Oh,
important
yeah.
because that's where you measure from.
What's the thing for number 4?
This is where you are actually measuring the angle on the simulator, like I showed you.
Oh, so you already told us how to do that? Okay, then never mind.
So I showed you how to do all this stuff for this page right here.
Okay.
And then this one, you're just kind of summarizing it. The next part is where you use the prism. So that changes the path of the light ray. But that one's kind of you experimenting around with it, seeing what happens. Because every, like a different shape of glass will also, like the way that it refracts will look different. So like your glasses, like whatever kind of glasses you have, they depend on how bad your eyesight is. They depend on if you're nearsighted or farsighted. But
That
they
hurts.
basically will change how the light that comes in will get to the back of your eye. So if you have bad eyes, it's because your lens can't refract the light well enough to focus on the back of your eyeball. But if you have glasses,
So people who
changes
have bad
the angle
eyesight just
of the
don't
light,
have.
and then the changed angle will hit perfectly on the back of your eye.
So people who have bad eyes, the reason they see stuff blurry is because their eyes just don't see the colors right.
It's not really about the colors. It's about the unless you're colorblind. But if you just see blurry, then that's because your lens like refracts light. It's because your lens can't change to the right shape.
Oh, okay.
There's different reasons that happens, but that's kind of why it's blurry.
Miss, have you ever wondered if the people who mute themselves are actually there? Like, who knows, they're just somewhere else.
I do wonder that.
They're here,
And that's
Scott.
why I like people to show their videos at least at the beginning.
I
Because
always show my video.
I saw this video where this kid,
Gary.
so he just muted him. Wait, no, he was unmuted, but then he had this tape recorder with just
Oh man. I mean, I've asked people questions before, not in this class actually, but in other classes. And I'll ask the question and they won't respond. So then I kind of know if they're there or not.
Sick.
Like, are you there, Nixon?
Yeah.
Hey, there it is. See, you guys are reliable. I can count on you. Most people are. Sometimes I think it's a microphone issue too. It's hard to tell.
Yeah.
Any other questions?
Hmm. Oh, why have you posted like the assignments up until May?
Well, because I planned it all, so I figured why not let you guys look at it?
Okay, then.
Yeah,
I wish other teachers would do that.
because it's hard to know what to do right now if you don't know where you're going, right? It's like
My
if you're
manual
trying to
teacher-
drive and you don't know where you're going, you're not going to drive very well.
Are we going to have a test anytime soon?
No, the way that I'm assessing you on this is the way that you choose to show it to me. So that's instead of a test or a quiz.
So instead of tests, we're doing projects? Well, mini projects?
Yep.
Okay, then.
So for some of you that will be better than a test. For some of you it might be worse than a test, but we do our best.
To be honest, I think my grades will become much higher because of this home learning thing.
Okay.
Yeah, me too. Because
You both have been very consistent in turning things in and asking questions, so I think your grade and your learning have improved, which is good.
I feel more
I knew
forced
it.
to finish stuff for some reason at home.
Good. Well,
Yeah,
that's
I
one
think-
thing you should not take for granted because that's not the same for everybody. Everyone learns different ways, but this
Is that
good for
Ken?
you, you can
Oh,
be
that's
thankful.
Edbert.
Yeah.
Hey, I didn't know Ken was here. How you doing, Edbert?
Good.
Good. You missed all
Yeah.
our help part of
You-
the Q&A.
You missed
got
the
any questions?
important part.
Oh,
Wait, Miss
wow.
Riddle, Miss.
Ah,
Oh,
what?
yeah, I actually do have a good riddle for you guys.
Yay, riddle time.
Okay.
Wait, what? What?